Welcome to another video from explainingcomputers.com. This time I'm going to talk about accelerated processor units, or APUs. These are microprocessors with integrated graphics capabilities and can allow fairly powerful PCs to be built without a separate graphics card. In this video I'm first going to consider APUs in general before looking at the performance of an A8-3870K APU kindly supplied to review by AMD. All early PCs had a central processing unit or CPU on their motherboard, as well as a separate graphics card to which their monitor was connected. More recently, many motherboards have been fitted with integrated graphics that allow a monitor to be connected directly to the motherboard itself. However, such integrated graphics have been insufficient for most gaming and graphical applications. As a result, most high-end and gaming PCs have continued to be fitted with a separate graphics card. These have been based around increasingly powerful graphics processing units, or GPUs, that are very good at tasks like decoding video and generating complex 3D graphics. While computers with both a CPU and a GPU continue to work effectively, it's potentially wasteful to fit a computer with two processing units. There can also be bottlenecks in the flow of data between them. Because of these issues, a new breed of chip called Accelerated Processing Units, or APUs, has been created. These incorporate both a CPU and a GPU and allow a PC without a separate graphics card to have good graphics functionality. Most modern processors, such as Intel's latest Celeron, i3, i5 and i7 chips, have an integrated GPU and are technically APUs. However, it has been chip manufacturer AMD that's been at the forefront of APU development and which now markets its processors as APUs. In 2006, AMD purchased graphics card manufacturer ATI, and since that time has been integrating more and more powerful graphics technology into its microprocessors that exceeds that of similar Intel chips. As a result, today AMD APUs offer the opportunity to build some of the best value multimedia and gaming PCs. The AMD A8-3870K is an entry-level 3 GHz quad-core APU. The chip costs around $100 US, £71 UK, and features integrated Radeon 6550D HD graphics. Here I'm fitting it into a Gigabyte A75M-S2V motherboard. This has both VGA and DVI ports for connecting a monitor, 2 slots for DDR3 RAM, 2 USB 3 ports, 4 USB 2 ports, and the usual network and audio connectors. The board currently retails for about $80 US, £55 UK. You may remember that I recently built a budget PC based around a dual-core Intel Celeron G530. If I'd completed that build with this quad-core AMD A8-3870K, it would have cost around $70 or £45 more, but with superior processing and graphics performance. So what I'm going to do is to remove the Celeron innards from my budget PC, swap in the AMD APU and motherboard, and then fit exactly the same 8 GB of RAM and drives so that I can do some proper performance comparisons. I of course need to put a heatsink on the APU to stop it burning up, and here I'm using an Arctic Freezer 7 Pro 2.0. This uses 3 heat pipes to draw heat away from the processor, comes equipped with a 92mm fan, and should prove more than sufficient. Right, well here we are with the system completed. It's all now built. I'm booting it up. This is not the first boot. Well, there's the BIOS screen, look. It's not the first boot because I've already installed Windows 7 64-bit Home Edition on this machine, so I can do some performance tests, show you how it works. Before I actually took the Celeron G530 apart, I also installed Windows 7 on that and performed some of the same tests I'll be doing here. So we'll have a chance to do some proper performance comparisons. Anyway, I've waited long enough now to get through the boot, I think, and you can see the AMD system. Coming up, Windows is welcoming us as it always tends to do. So here we are. I think the first thing we'll do is we'll just right-click my computer, look at properties, and I will show you the Windows experience measurement for this machine. As you can see here, we've got a Windows experience measurement of 5.5, but that's actually constrained by the speed of the hard disk, which is surprising because that was a very fast disk when it was first purchased. But just to show you in comparison, we're running here a processor score of 7.3 versus 6.3 on the Celeron G530. We've got a memory score of 7.3, which is slightly strange because we had 7.4 before and it's exactly the same memory. We've got a graphics score here of 5.9 versus 4.9 previously on the Celeron. We've got a 5.5 graphics on the Celeron versus a 6.6 here. And the disk is still at 5.5. So this shows us immediately that the machine here is now more powerful with the AMD A8-3870K installed. We're perhaps hardly not surprised at that. So the next thing I'll do is to get rid of this, and I'll bring up some more sophisticated performance software. This is actually from a company called Passmark. This is their performance test 8.0, and I'm going to run here a whole set of tests. I'm going to actually run all of their tests. It'll take a while to flick through, and I'll speed through some of them. But basically this is going to test out the processor, it's going to test out the memory, it's going to test out 2D and 3D graphics, and we'll get some proper benchmark graphs to actually compare performance and see how well this machine is doing. As these tests are running through, you may notice there's two sets of bars appearing. The red bar shows the score for the Celeron G530, which I've loaded in from a previous file, and then the green scores of this machine. It's now testing 2D graphics, putting up all these lovely exciting symbols, drawing pictures of elephants and lions in the jungle. It does a whole range of tests. I quite like Passmark as a piece of software. It's not too expensive to buy compared to some of the test bits of software, and you can install it on a USB key and then go and put it into different machines, get a ranking, and then load them back in and compare how machines are doing. It's testing here the speed of still 2D graphics. Right, we've now got to the bit most people are most interested in. This is 3D graphics. It does a range of tests here. This is a very straightforward DirectX 9 test, and it's achieving about 60 to 70 frames a second. It's depending on exactly where we are. We'll do some more detailed analysis of this later on. It's now doing a bit more sophisticated test of DirectX 9 graphics, and still achieving a decent frame rate. Again, I'll show you some comparisons later. Oh, look at that water, that's looking very nice for the power of the APU is coming through there, I think. Okay, it's now reached DirectX 10 test. It's now starting to struggle a little bit. As you can see, the frame rate here is not fantastic. This is a little bit of a stretch for the machine. And it's now doing a DirectX 11 test, which in fact you won't see in the other machine because it couldn't run it. Oh look, we've got floating jellyfishes in space, which is a well-known problem these days, isn't it? Okay, we're now doing some very pretty looking graphics tests, and those are all, as I can see, finished. And it's now going to do some basic tests of things like memory, etc. So I'll speed through these till we get to the end of the benchmark. Right, it's finished. It's now come up with a pass mark of 1331.5, which is of course a meaningless figure without comparison. So I'll tell you straight away the pass mark on the Celeron G530 was a 932, so it's clearly a more sophisticated machine here. We won't send that online right now. And we can see here the performance comparison. This computer is the green bar at the bottom, the Celeron's the red one at the top. So clearly a faster machine in terms of the overall pass mark rating, but beating considerably on the CPU. It's actually losing out slightly on 2D graphics, not by a lot. It is beating it significantly on 3D graphics by a factor of over a factor of 3 times, which for gaming is clearly very important. The memory market again came down lower as it did on Windows. A bit strange because same memory. Must say something about the motherboard, and the disk mark has somehow got slightly faster, which just proves you can't take too much of the subtleties in these tests too far. If we compare the 3D graphics performance here, this shows all the different 3D graphics tests run. You can see a significantly improved performance from the AMD A8-3870K rather than the Celeron. As we said, the pass mark itself is massively higher, but if you're looking through, the DirectX 9 test is, massively greater, as is the more complex DirectX 9 test. DirectX 10 test is over twice as good, and the DirectX 11 test, which couldn't even run on the Celeron machine. So we're looking at quite reasonable performance there. I thought I'd also show you some comparisons with a couple of other machines. Here I've loaded in some pass mark benchmarks for a Core 2 quad machine. It runs at about 2.8 gigahertz. That's obviously a quad-core processor, which is running with GeForce Q9550 graphics. This is represented here in blue. It's a machine I know very well indeed, because it's the machine I do all of my video editing and animation on, so it's the one that's closest to my heart for this type of work. And I've also loaded in a benchmark for Intel Core i7-950, which is equipped with a Radeon HD 4350 graphics card. That's here in the yellow. So if we just quickly look through these, you'll see that this computer compares very well against the i7 in terms of the overall pass mark rating, and it's almost up to the Core 2 quad. When we start to get down the CPU market, inevitably falls off a bit. When we look at 2D graphics, we're not doing too badly. When we look at 3D graphics mark, you can see this machine is still doing very well. And if we look at the 3D graphics, you'll see this machine is outperforming everything there. I find that quite annoying, given what my main machine is used for. Again, DirectX 9, complex and simple tests, and the DirectX 10 text. There really is a very interesting comparison there. And again, this is the only machine which will run the DirectX 11 tests. However, just before you get the impression this machine is the fastest thing ever, which it isn't, it's still a budget PC, I've now loaded in a benchmark provided by Passmark. This is a 3.5 gigahertz i7, which is loaded up with a GeForce GTX 680 graphics card, so a really high-speed system there. And you can see that whilst our green mark here is still doing well against everything else, against this purple mark for that very high-spec system, it is clearly starting to lose out. And particularly if we look at the graphics performance, you'll see that that's what happens when you put in a separate graphics card of a very high spec. Perfectly possible to beat older systems and other systems with integrated graphics, but a graphics card does add something if you really need that power. However, let's go back to our comparison of the Celeron G530 and this machine, and I thought I'd just show you a comparison directly of the 3D graphics test for the DirectX 9 complex simulation. And I think running this is a very interesting comparison. You're getting well over double the frame rate on the AMD machine, the APU, and particularly if you look at things like the water, the actual quality of the rendering is clearly massively better. You're just not getting anything like that on the Celeron machine. So I think we're demonstrating here, if you spend a bit more money on your gaming machine, you do get a significantly improved experience. As I've demonstrated in this video, it's now possible to build a respectable low-cost gaming or multimedia PC based around an APU such as AMD's A8-3870K. In time, it's also likely that, due to the existence of APUs, fewer and fewer PCs will be fitted with a separate graphics card. But now that's it for another video, and I hope to talk to you again very soon.